Are you in a square peg business? Most people are, because that's how you make money. More pegs, more holes, better, faster, cheaper. That's how you beat the competition and win in the marketplace. Now, business school professors have a lot of fancy names for all this stuff, like strategic DNA and core competency, continuous improvement, process optimization. But when your square peg business hits a round hole world, all that stuff really means is that you're going to continue to get better and better at a bunch of stuff your customers care less and less about. So what do you do about that? That's a really tough problem. That's why good businesses fail. Not because a bunch of smart and ambitious people all of a sudden become stupid and lazy, but because their square peg business hit a round hole world and they lost relevance. It can happen to anybody. Eventually, it's going to happen to you, and you're going to have to figure out what to do about it. One thing you can try is go and look at what some smart, successful people have to say about the problem. This is Tim Cook. He's the CEO of Apple. Very smart guy. Runs a fabulous business. I mean, obviously, right? And what he says that you need to do is drive responsibility for creativity and innovation throughout your enterprise. Make everybody accountable for it. And he goes on from there. He says, the one thing that you don't want to do is you don't want to set up some sort of innovation department or appoint somebody like a vice president of innovation. Because once you do that, I mean, it's over. You might as well just put a for sale sign on the door. But apparently Google never got the memo, because that's exactly what they're doing at their X division, what they call their moonshot factory. So now what do? Do you innovate the Apple way or the Google way? Maybe neither. After all, Apple hasn't launched a hit new product in over a decade, and Google even longer than that. So maybe you need to find your own path. Because the only true guarantee is that eventually every square peg business hits its round hole world. Everybody is disrupted. It's only a matter of time. And you're going to have to figure out what you're going to do about that. A good place to start is by beginning to understand what disruption really looks like. And quite often, it looks a lot like this sweet old guy, Charlie Bennett. Does anybody have the faintest clue who Charlie Bennett is? Didn't think so. Charlie is mind-blowingly brilliant. I mean, Charlie's so smart that you ask a lot of other really, really smart people, you mention his name, and their eyes just glaze over, because Charlie is truly in a class by himself. Now, when he was growing up back in the 1950s, he was, at least as he put it to me, he was a geek before geeks were cool. So while all the other kids were running around playing sports, trading baseball cards, what really inspired Charlie was Watson and Crick's discovery of the structure of DNA. Charlie's a little different. So he went to college, he majored in biochemistry, and then he went to Harvard to do his graduate work. And there, being a truly exceptional student, James Watson actually chose him to be his teaching assistant. So Charlie spent a lot of time explaining to undergraduates how these long strings of RNA would migrate out of the nucleus and meet up with ribosomes, throw off amino acids that create the proteins that build structures and regulate processes in every cell in our bodies. And then one semester, he decided to take an elective course on the theory of computation. And for the first time, he saw the concept of a Turing machine. Long strings of code that go through a single reader and throw off universal computation. And he thought to himself, gee, that seems a lot like that stuff I'm teaching those kids in Watson's class. And he thought, like, wow, DNA is actually some kind of computer. And nature can create computation all by itself. That is just the coolest thing ever. So Charlie never became a geneticist. He went to work for IBM as a research scientist. And he did some important early work in some theoretical areas like reversible computing and some other stuff. But his big breakthrough came in 1993. That's when he led something called the quantum teleportation experiment. And this was important for two reasons. First, it helped disprove one of Einstein's final theories. And second, it led Charlie, just a few months later, to write down his 4 laws of quantum information. And I know that sounds incredibly abstract. And it is. But that's what it looks like. That's what disruption looks like. The next big thing always starts out looking like nothing at all. That's what makes it disruptive. If it was obvious, we wouldn't miss it, and it wouldn't be so disruptive and dangerous. So let's bring Charlie's idea into a little bit more focus. This is Jay Gambetta, another obviously much younger scientist at IBM. And he's holding in his hands there a tablet computer, which is, of course, hundreds of times more powerful than the original IBM PC. And that's because of something called Moore's Law that doubles computing power every 18 to 24 months. It's been going on for 50 years. But that's not what's interesting about this picture, not the continuity of that tablet computer, but the discontinuity of what it's connected to, which is a quantum computer based on Charlie's ideas that has the potential to be thousands, if not millions of times more powerful than the technology we use today. So how's that going to affect your business? Well, for starters, it's eventually going to make all of our encryption algorithms obsolete. So if your business involves any transactions like selling things to customers or buying things from suppliers, it's going to have a pretty big effect. That's just for starters. Applications currently being explored range from artificial intelligence, pharmaceutical research, materials science, managing large and complex financial portfolios. But the truth is, all that stuff's still a ways off because these things don't work that well yet. So let's see where quantum computing fits on the Gartner hype cycle. And I'm sure those of you with telescopic vision have probably already spotted quantum computing. It's sitting right there, in the middle of like 20 other things. And like those 20 other things, it's going to get hyped up to this peak of inflated expectations, come crashing down to the trough of disillusionment, slowly start creeping its way up the slope of enlightenment until it hits the plateau of productivity and starts affecting our competitive environments in 5 to 10 years. So I think maybe you can start to see the problem. And by the way, this greatly undercounts the problem because Gartner mainly follows information technology. It doesn't follow things that are going on in material science and nanotechnology and genomics and CRISPR and all the other stuff. So I think maybe you can start to see the problem, though. How do you keep track of all this stuff and still do the things you need to run your business? You know, that pesky stuff like developing new products, servicing customers, paying bills, managing employees. The answer is simple. You can't, and you shouldn't even try. But what you can do is focus on problems you can solve out in the marketplace and within your organization. And that's what has the power to transform all that Amazing technological advancement from a source of disruption to a source of incredible possibility and opportunity. How do you do that? That's what I wanted to know. That's what started me on the journey that led to my book. I went out and started researching and talking to every great innovator I could find, from top executives at major corporations to world-class scientists to startups of every size and shape you can imagine. And they were all very, very different. But I found that they all had one thing in common. There's one thing they all did differently than everybody else. And that is they all had a systematic and disciplined process to identify new problems. They all had different ways of solving problems. But that's the one thing that seemed to be the secret sauce. It was the only thing I found that every single great innovator I came across did. This is Eric Haller. He manages something called data labs for Experian. And what Eric noticed was his company was getting trapped in its own P&L. Anything that couldn't be immediately quantified was an absolute non-starter. So he created data labs which has no P&L. Doesn't have revenue targets, anything like that. What it does have is one mission. Go to customers, find out what problems they need solved. Or as Eric likes to say, what's giving them agita? What's driving them nuts? When they find a problem that seems to have potential, they take it back to data labs, which is stocked full of world-class data scientists. They can usually turn around a prototype within 90 days. They take it back to the customer likes what they see, they co-create a more complete solution. Eventually, it goes back to one of the operational units within Experian to be scaled up into a real business. Over the past 5 years, Data Labs has launched more than a dozen multi-million-dollar businesses this way. And it's become an engine of growth for a $4 billion company. IBM has a similar idea, which they call grand challenges. You've probably heard of the most recent one, the Jeopardy Grand Challenge, that led to their Watson business. They had no idea it was going to lead to a business or what kind of business it was going to lead to, but they just wanted to solve a problem. And now Watson's become an engine of growth for IBM. But they're not looking for problems that will take them 90 days to solve. They're looking for problems that will take them years and sometimes decades to solve. Google's 20% time acts as like a human-powered search engine for problems because it knows if somebody's 20% time project starts attracting a lot of people to work on it, that's probably a pretty interesting and important problem. So different organizations go about it in different ways. But all the ones that were able to innovate consistently, not once or twice, but year after year, decade after decade, had that one thing in common. Systematic and disciplined process for identifying new problems. This is one of the most interesting and inspiring people I ever came across. His name's Jim Allison. Does anybody know who Jim Allison is? Didn't figure you'd know that one either. Anyway, he told me just in his really pleasant South Texas twang that he really just likes figuring stuff out. And that's what he's done all his life. When he finished grad school back in the 1970s, they had just discovered T cells. And he thought it was so cool how these things would whip around your body and kill stuff for you, but not actually hurt you. But nobody knew, had the faintest idea how it all worked. So he said, that's what I want to do. It seems like a lot of stuff to figure out. That's what I'll do with my life. And he did. Over the next decade or two, he and his colleagues figured out a lot about how our immune system's regulated. Turns out there's one receptor called B9. Works like an ignition switch in a car. It gets everything started. And there's another receptor called CD28, which acts as an accelerator. It revs our immune system into high gear. And there's a third called CTLA4 acts as a brake, shuts everything down. B9, CD28, CTLA4. Sounds like gibberish to most of us, yeah? But to people like Jim, it's like tools of the trade. You can imagine if Jim came of age in the time of Henry Ford, he would have been in some garage somewhere tinkering with engines. But he made immune regulation what he was tinkering with. And by the mid-90s, he started to think, by observing what was going on in his lab and those of his colleagues, that maybe, just maybe, the problem with cancer was that not that our immune system can't identify cancer cells, but that it just puts on the brakes too soon with the CTLA4 thing. See, maybe if we can pull those brakes off, we can find a new way of fighting cancer. So he goes back to his lab to start figuring it out. And he did these mouse studies, and he told me the results amazed him. He said that it was almost like the tumors were melting in front of his eyes. So he went to all the big pharmaceutical companies to tell them about his discovery. And they said, anybody guess? No way. We're not touching it. We were playing around with all this immunocancer stuff back in the 1980s. We went through hundreds of trials. We blew through billions of dollars. We're never doing that again. And Jim told me how depressing it was. Here he had something he felt could really make a difference. And nobody wanted to back it. But then he figured, I'll just figure that out too. So he went back to the lab, validated his results further, pounded the pavement. Finally, after 3 years, he found a small biotech company willing to invest. 2004, clinical trials started. A young woman named Sharon Belvin was one of the first patients. She was only 22 years old, had just a few months to live. She had a very aggressive form of melanoma. They tried chemo, radiation, you name it, nothing worked. So when her doctor came and said, would you like to enter this clinical trial for this new experimental treatment? She said, sure, why not? I've got nothing else to lose. She started the treatments. Within a few months, she was in remission. Today, Sharon is in her mid-30s. She's a fitness instructor. She's got 2 kids, and she has been cancer-free for over a decade. And of course, cancer immunotherapy is no longer considered speculative. It's considered a major pillar of cancer treatment. And that small biotech company was bought by Bristol Myers Squibb for almost $3 billion. And Jim, most people figure he's on the shortest of short lists for the Nobel Prize. So if you want to know the secret to innovation, that's it right there. Find a meaningful problem and start figuring stuff out. And that's the final idea I want to leave you with today. Because the biggest misconception about innovation there is that it's about ideas. It's not. It's about solving problems. So if you want to innovate, don't go looking for some great, fantastical idea. Go out and find a good, meaningful problem and start figuring it out. Thank you very much.